Hello children, welcome to Zero Panic Maths. In today's session, let us start with a new chapter, chapter 2, that is Introduction to Polynomials. Okay, so polynomial is a special type of algebraic expression as it is given in the simple definition, that it is a special type of algebraic expression. Okay, and that algebraic expression contains some variables, some constants, some coefficients. Okay, and there are terms involved in that. Now we will see what exactly is a polynomial, types of polynomials, and some of the examples with real-time problems. Okay, now to understand as an introduction of a polynomial, let us simply start with a simple example. Okay, so example 1, uh, read it carefully. Okay, Raju went to a shop where there were sealed boxes of different colors on sale. Okay, so different boxes with different colors were there. Okay, and the shop owner told him that red boxes have 4 pens. Okay, mark this. Okay, this information will be helpful for us to represent this information into an algebraic expression. Okay, red boxes have 4 pens, okay, each, and the blue boxes have 5 pencils. Okay, there are 4 pens in red boxes and 5 pencils in blue boxes. Okay, now if Raju bought x red boxes, remember this, and y blue boxes, how can he quickly figure out the total quantity of pens and pencils? How many pens he bought and how many pencils he bought? In addition to that, there is some additional information that given, that if he got 3 extra pens free, then we have to find that how many pens and pencils did he got altogether. Okay, now this information is very simple, but we are trying to understand what exactly is a polynomial is first. Okay, and then we will go for what exactly is a linear polynomial. So we are trying to understand what is a polynomial. So given information is represented in the form of an expression. How are we representing it? You can see that 4 pens in a red boxes, and how many red boxes he got? X red boxes he got, x red boxes, and y blue boxes he got. So if he gets, listen to me carefully, if he gets one red box, 4 pens he will get. Okay, so if he gets 2 red boxes, 8. Then in general, if he gets x red boxes, you can see that here it is given as x red boxes, then 4 into x is the total number of pens he bought. Okay, so that is actually given here. 4x is the total number of pens. We are representing the x number of red boxes multiplied by 4 pens, which is the red box containing 4 pens. So 4 into x is the total number of pens he bought. Okay, similarly he bought y blue boxes. Okay, and each blue box contains 5 pencils. That is 5y is the total number of pencils he bought. We are summing up all together because they have asked it as all together. Total number of pens and pencils together they want, and in addition to that there is a constant because they have given 3 extra pens for free. Okay, so that is 3. So all this information we have represented in the form of an algebraic expression, 4x plus 5y plus 3. Okay, we have some different definitions we need to concentrate on. So as you might be knowing it, if there is a number which is not having any coefficients or variables together with this, that is called as a constant. So 3 in this expression is a constant. You might be knowing this. Now, and along with x and y. Okay, so first of all we'll see what is x and what is y. What is x and y? It is called as a variable because the value of that may vary. Why we are calling x and y are variables? Because those are the general values. See, they are saying x red boxes, they are not saying 10 red boxes or 20 blue boxes. Okay, so x and y might take any value. That is why the value of x and y may vary. That's why we call them as variables. So in this expression x and y are variables. 5 and 4 are coefficients of x and y. Okay, 4 is a coefficient of x, 5 is a coefficient of y. Together with the sign of the number we need to take into consideration. Okay, so since it is plus, I am saying it as a 5. If it is minus, I should be saying minus 5 is the coefficient of y. And this together with the coefficient and the variable is called as a term. Okay, similarly 4x is a term, 5y is a term, and 3 is also a term. So how many terms are there in this expression? 3 terms. Okay, so together with variable and the coefficient is called as a term, and this is coefficient, this is constant. So these are the different parts of the algebraic expression, or you can call it as a polynomial. And this is a polynomial in two variables, and that is x and y. Okay, you understood this? Okay, now I took some little more time to explain this because this is the first example. We will see some more examples which are similarly explaining us how do we convert the real-time problem into an expression or a polynomial. Okay, so let us see the example 2. Listen to me carefully. Okay, example 2 says a rectangular garden of length L meters. Okay, so it is L. Okay, it is L, length L meters and width W meters, so in generally they are saying L meters is the length and W meters has to be is the width of that, and has to be fenced and decorated. So they want to put a fencing around the garden. Okay, now let us assume, if you are seeing this, let us assume this is the garden given. Okay, this is the image given in the book. That I've just copied it here to explain you better. Okay, so assume that this is the width. Okay, you see that here it is W, and this is the length. This is the length, and say suppose it is L, they are saying. Okay, this has to be fenced. Okay, the fencing is the towards the circumference or the towards the perimeter of the rectangle. They are putting some wires for the security purpose. That is called as fencing in general. Okay, so they want to fence it with different materials. And what are those materials? They have explained it here. A wire fence is to be laid along the length, costs rupees 100. Listen to me carefully. Okay, rupees 100 per meter, rupees 100. So throughout the length of this, here at the right side and the left side, they want to fence it with a wire fencing towards the length. See, you can see here there is a wire fencing and the left and right side. And how much does it cost? It costs 100 rupees per meter. Okay, and similarly a wooden fence is built along the width, and how much does it cost? It is 80 rupees per meter. You can see the wooden fences here, towards the width of that. Okay, on the width side, and that how much it costs? 80 rupees per meter. Special seeds have to be sown throughout the garden, which will cost 50 rupees per square meter. Okay, and inside the garden, they want to sow some special seeds. Okay, now when they are saying in throughout the garden, it means throughout the area of the garden. So in that case, we need to multiply length and width to get the area of the rectangle. Okay, and that area should be sown throughout the garden, and that area costs 50 rupees per square meter to sow that seeds. Okay, now what is the real problem? The problem is, what will be the total cost incurred? See, here after reading all this problem, you need to understand what all information is given and how do we convert that information into a algebraic expression. Now think carefully and decide about how do you calculate the total cost incurred. Okay, so there are three different informations given. That is 100 rupees per meter is one fence cost, and 80 rupees per meter is another fencing cost, and 50 rupees per square meter is another cost that is incurred to sow the seeds along the throughout the area of the rectangle, area of the garden, you can say. So how do we calculate totally cost of wire fencing along the garden length, along the length. Okay, now see, the length is given at the two side and width is given by the two sides. Okay, so length, as they have said, it is L meters, so 2 L meters is the total length of wire fencing. You understood this? So that's why we are saying what is the cost of the wire fencing. It is along the length, so it is 2 times length, 2L, it is 2 times length into 100, because 100 is the cost per meter for the wire length. So it is 2L into 100, it is rupees 200L. It is rupees 200L. Okay, understood this clearly? Okay, now similarly, cost of wooden fencing, because wooden fencing is done along the width of the garden, it is 2 times width, because it is in the front and in the back, it is 2 times the width of that. And how much does each meter of the wooden fence costs? It is 80 rupees. So it is 80 into 2, 160 times the width. So 200 times length and 160 times width is the fencing cost. But along with the fencing cost, we have the cost of sowing the seeds also. Okay, throughout the entire garden, and since it is entire garden, it depends on the area. How do we calculate the area of a rectangle? It is by width and length, multiplying length and width, it means that. Okay, now how do we do that? It is the area is length into width. Okay, you consider it as L. Okay, length and width is the area, and throughout the area, how much it costs per square meter? It is 50 rupees. So 50 into the area is 50 times length into width is the cost of sowing the seeds. So total cost is sum of all these three, and that is total cost is equal to rupees 200 times length and 200 times width and 50 times length into width, 160 width. Okay, so the algebraic expression is 200L, finally 200L, 160 width and 150 length into width is the algebraic expression that represents the total cost that is required in the problem. Okay, hope you understood this clearly. Let us see one more example. Okay, now listen to this problem carefully. Okay, example 3 says a wire of length 20 centimeter is bent into different ways to form the rectangles. Okay, so the total length of the wire is 20 centimeter. Okay, with that 20 centimeter only you are forming a rectangle. So it means that a perimeter of the rectangle is 20 centimeters. Okay, uh, so now, for example, we can have a rectangle with length 7, okay, and width as 3 centimeter. Okay, now try to assume this length as 7 centimeter and width as 3 centimeter. If you are forming a rectangle, this is an example given. So length 7, so it is also 7, opposite sides are equal, so this is width 3, so this is also 3. So total perimeter is, it is 7 plus 7 14 plus 6 20. Okay, so the total wire length to throughout the perimeter of this rectangle, it is 20 centimeter they are saying, and they have given one example of forming a rectangle. Okay, now we can also have one of the length as 5.5 and width as 4.5. That also makes a rectangle with perimeter as 20 centimeter only. You can take that also as an example. They are given like 5.5 as one length and 4.5. Okay, you see that this also makes a perimeter with 20 centimeter. Correct? 5.5, 5.5, it is 11 plus 9, that is 20 centimeter. So that way they are forming different rectangles of different length and width, so that the perimeter will be a constant, that is 20 centimeter. Okay, then they are asking of think of few more ways to form such rectangles. Okay, can you write an expression for the area of such rectangles? Can we write an expression for area of such a rectangle? We will write that. Okay, but before that, we'll think of few more ways of forming this. Now see, suppose when you have rectangles of different length and width, so that 20 centimeter is the perimeter. Suppose if I say 8 is this, 8 is the length of this, this is also 8. So how do I think of it is so it is 2, so that it is 2. Okay, you see that 8 into 8, sorry, 8 plus 8, 16 plus 4, that is 20. Now if you take it different way, suppose if it is 4, if I take it as 4 and this is also 4, it is 8 now. So I want this to be 6 and 6 width. Okay, so that it makes it 20. So in general, if you consider, you see that in general, if x is the length of this, x is the length of this, how I am considering the width is 10 minus x. Width is 10 minus x. Why is that so? See, you can see that here. If 5.5 is there, 4.5, that is 10 minus 5.5 is 4.5. If it is 3, see, if it is 7 is the length, then 3 is the width. How did you got 3 is 10 minus 3? So in general, how are we finding the width is 10 minus x? So it is length is length. If you consider length as x, then width is 10 minus x, and that is the way to find out the generic way of finding the area of this rectangle. Okay, now say suppose if the length of the rectangle we are considering it as x centimeter, as I told here, then the width will be 10 minus x centimeter. Why? I already told you that. Okay, now assuming that x is the length and 10 minus x is the width, how do you calculate the area? Area is equal to, therefore area is equal to x into 10 minus x. Correct? X into 10 minus x, because length into width. Okay, and that will give us 10x minus x square. So I'm just taking this as an example here, 10 minus x. Okay, so if you multiply it, 10 into x, it is 10x, and x into x, it is x square. So this is an expression for the area of these rectangles with x as the length and 10 minus x as the width. And this is specific to a wire of length 20 centimeter, which is considered as the perimeter of this rectangle. Okay, you understood this, and you can think of few more ways of forming such a rectangle, that as I told you, that if you consider x, 10 minus x can be that different way of thinking that. Okay, now if you consider 3, that is 10 minus 3, which is 7. If you take an example, 7 plus 7, 14, and plus 3 plus 3, 6, 14 plus 6, 20. You can take any example considering x as length and 10 minus x as the width, and that will give you the answer for this question. And answer for this question is this. Understood this? Okay. Now let us see some more examples that represent the algebraic expression, which we can call it as a polynomial. You can see 4x is also one of the algebraic expression in one variable. X square plus 1 is one more example. 2y minus 5. 5y cube plus y square plus 2y minus 1 is another expression, and 3z plus 7. Some more examples that can be considered as algebraic expressions that involve only one variable. Okay, in all these expressions you can observe that there is only one variable, that is either x or y here or z here. Okay, so an expression, such an algebraic expression involving only one variable, and its powers are x square or x cube, like that. Okay, and its power is called as one variable polynomial. Okay, it's a simple definition. Because it has only one variable inside it, it is called as one variable polynomials or univariate polynomials. Okay, or you can simply call it as a polynomial also. When we get into more details of the concept, we can call them as polynomials also. Okay, now in addition to that, you have one more information that can be defined based on the power of that variable in that expression or the polynomial. Okay, so you can define one more information, that is degree of a polynomial. What is degree of a polynomial? It's very simple, that the highest power of that one variable. Okay, first of all, it should be a one variable polynomial. Okay, and the highest power of that variable in that polynomial is called as degree of that polynomial. Say for example, uh, degree of this polynomial is 2 because the highest power of the variable x in this case is 2. Degree of this polynomial is 3. Okay, because it is a polynomial in y and the highest power is 3. It has a power of 2 1 also, but highest power is 3. Here the degree of this polynomial is 1 because the z, which is the variable in that polynomial, has the highest power as 1. Okay, now based on the degree of the polynomial, we can categorize these polynomials into different types. What is the cubic polynomial? As the uh, name suggests, cube is 3, right? So the polynomial in which the power of the highest power of the variable is 3 is a cubic polynomial. So the example for this is cubic polynomial. So you can take cubic polynomial example like x square plus 4x plus 1. It is a cubic polynomial. In x, it is a polynomial and variable's highest power is 3. So it is x cube. Okay. Now quadratic polynomial, quadra, as you know that quadrate means 2. Okay. So quadrate as the name indicates, the expression or the polynomial in which the variable's highest power is 2. Simple. Okay, that is x square plus 1. Okay, here x is the variable and its highest power is 2. Linear polynomial. Now here comes the definition, the exact definition, that what we wanted to discuss. Linear polynomial. Okay, now as the name indicates, linear means in a straight line. Okay, and we'll come to know why we call them as linear polynomial. But here the linear polynomial is a polynomial in any variable whose highest power is 1 in that case. So it is 2y minus 5. Okay, here even 4x is also a linear polynomial because x power is highest power is 1 in this case. Okay, so you understood what is a linear polynomial is. Now in addition to linear polynomial, we may have a constant polynomial also. Okay, and what is the constant polynomial? We have only the constant value. Okay, 3 which is a constant value can also be called as a polynomial, so that what is less than 1 now? What is less than 1? It is 0. Okay, in which the polynomial in which the variable's highest power is 0 is called as a constant polynomial. Okay, so if there is a constant, along with that you can have, you can always imagine there is a variable with power 0. Okay, what is x to the power of 0? That is 1. 3 into 1, that is 3, constant 3. You understood this? Okay, so constant is 0. Linear polynomial is a polynomial with variables highest power as 1. Quadratic is highest power 2. Cubic means the power 3. You understood this? Okay. Let us see some exercise sets based on whatever we have studied till now. Okay. Now simple. This is a simple exercise set. We can go fast. Okay. Find the degrees of the following polynomials. So by looking at the polynomials, you have to find out the highest power of a variable in that polynomial, and that is the degree of that. Okay. Now let us try to understand what is the degree of this polynomial. You can see that it is a variable in x and the highest power is 2. So this is 2. What is the degree of this? It is a variable y in which the polynomial is defined, and you can see the polynomial's highest power is 3. So that is of degree 3. Here you can see this is a constant polynomial. This is a constant polynomial, and there is no x term, but you can consider this as x to the power of 0 or y to the power of 0, any variable to the power 0 it should be considered. So what is the degree of this constant polynomial? That is 0. And here it is a linear polynomial because the variable z, which is the variable in this polynomial, has the highest power as 1. So what is the degree of this? It is 1. Simple. It's a simple. Now so to the second question, write a polynomials of degrees 1, 2, 3. You can have the answer from this set only, okay, or else whatever way you think and write the polynomials of degree 1, 2 and 3, I can write the answer from here only. See, it is the answer to, see, degree 1 is this polynomial. You can write it as an example. I will write it as 4x minus 3. Okay, instead of z I have taken x, 4x minus 3 with degree 1. Degree 2 is 2x square minus 5x plus 3. You can change the values and say 4x square plus 5x plus 1. Any values you take, but you should be keeping the highest power of the variable in that polynomial as 2. That will make the quadratic polynomial with degree 2. Now similarly with degree 3, you have the answer here. I will write it as z square plus 4z plus 1. Anything you can take. Okay, so that is, sorry, it is not z square, it is z cube I'll consider, and 4z square, or you assume that z square term is not there in that polynomial, that is also okay, but it should have the highest power as 3. Such a polynomial is called as of degree 3 and a cubic polynomial, you know that. Okay. Okay, now what are the coefficients? The third question, it's simple only. What are the coefficients of x square and x cube in this given polynomial? Okay, and I already told you in the beginning, very beginning, that while considering the coefficients, you should be very careful. You should consider it with along with the sign also. Okay, so what is x square? X square term is there here. So what is the coefficient of x square? That is 6. So it is with plus sign. What is the coefficient of x cube? X cube's coefficient is minus 3. So 6 and minus 3 are the answer for the third question. Understood this? Okay. Let us see the next set of questions. In exercise set 2.1. What is the coefficient of z in this polynomial? What is the coefficient of z in this polynomial? You see that? Okay. This is just before example that I was discussing, that even if all the terms are not present in the polynomial also, then also it's okay, but you need to consider it based on the power, that how do you define the degree of the polynomial. Okay, now suppose here we don't have the term with z. What is that I'm trying to make you understand is, even if the z term is not there in this polynomial, we can find out the coefficient of that. How we can call it as 4z cube. Okay, it is the term with cube. Okay, and then 5z square. Okay, and plus you can call it as term 0 z, 0 into z. Okay, and minus 11. I have just modified this given polynomial with a term z with coefficient 0. Okay, since the coefficient of that is 0, this term was removed from this polynomial, and only this part and this part is given. So what is the coefficient of z here? Is 0. You can write it as 0. It's a simple example. Okay, now what is the constant term in the polynomial 9x cube plus 5x square minus 8x minus 10? Constant term is this, which is with no variable, or you can say the variable with power 0. Okay, so that is the constant minus 10 in this example. Okay, these were the simple examples given in exercise set 2.1. Okay, we will see some more important concepts and the definitions. Based on that also we have some more examples. Now the second concept here is linear polynomial. Now we are actually going into the specific part of this chapter, that is linear polynomial. So you know that what is a linear polynomial? Linear polynomial is an algebraic expression with one variable whose highest power is 1. Okay, so you can say, for example, the perimeter of a square of side x is 4x. That is a linear polynomial. That is an example of linear polynomial. So if it is a square, all the sides are x in this case. Okay, so what is the perimeter of this? 4 times the x. Okay, and that is a linear polynomial in variable x, where the constant is 0. Okay, so the linear polynomial is with power 1, right? Okay, it is 4x plus 0. There is no constant term here, but that is also called as a linear polynomial. Let us see one more example to represent the linear polynomial only. Okay, now let us see here. A chess club charges a joining fee of rupees 200. Okay, there is a chess club. To join that, joining fee is 200 rupees, and for playing each match or each play, okay, you need to pay additional 50 rupees per match we have to pay additional 50 rupees. The following table shows the amount a player will have to pay as the number of match varies. Okay, so there is a simple table here. The number of matches played, if he play one match, he will have to pay 250 rupees. Okay, the second row here is the amount paid in rupees. Why 250 rupees? Because 200 is already paid as a joining fee. So whatever value that you see in all these columns, all these cells are 50 rupees added per match in addition to the 200 that is given as a joining fee. You understood this? Okay, so 250 for one match, 300 for two match, for 5 matches 250 plus 200, it is 450 rupees. So in generally, finally when he plays m number of matches, 200 rupees paid as a joining fee, and m is the number of matches multiplied with 50 rupees, which is the per match fees. Okay, so in generally, to find out for m matches, the total cost to be paid is 200 rupees plus 50 times m. Okay, so you can see that if m is the number of matches played, the total cost will be always 200 rupees and 50 times m. Okay, you can observe here that in every match, after every match played, the value that is getting increased is 50 rupees. 50 rupees, you see that 250, 300, 350, 400, 450. So 50 rupees is the constant amount increased for every match he played. Similarly, for the previous example also, you can see for every 0.5 centimeter increase in the side, you will get a constant 2 centimeter increase in the perimeter of this. You can see that. See, 0. Means half centimeter. If I increase the length of the side, totally 2 centimeter perimeter will be increased. Okay, and that is the constant only. So it means that you can observe a linear pattern, and that is called as a linear pattern. Okay, what is the linear pattern is either the constant increase in the value or constant decrease in the value of a total expression is depending on the variable. Okay, so that's why we call this 200 plus 50m as a linear polynomial in variable m. With increase in the m, the whole value is getting increased by 50, 50, 50, and that is the constant. Okay, so the whole value of the expression is getting increased by 50 rupees with increase in the m. That is what is called as a linear pattern that we observed in both example 4 and 5. You understood what is a linear pattern is? The constant increase or constant decrease. That's all. That simple it is. Okay. Okay. Now let us see one more example. listen to this example carefully. It's very, very important. It says the sum of two numbers is 64. The sum of two numbers, we don't know what are the two numbers, okay, and the sum of the two numbers is 64. One of the number is 10 more than the other. One of the number is 10 more than the other. So if one number is x, then x plus 10 or 10 plus x is the another number. What are the two numbers? It's a simple definition. The sum of the two numbers is 64, okay, and one number is 10 greater than the other number. So simple, you know that, you might have studied such examples in your previous classes. Let the smaller number be x in that case, okay. So if you don't know what exactly to be found, you have to start with an assumption of x as that value, okay. So let us consider the smaller number as x. Now, as I told, then the larger number will be x plus 10. Okay, since that number is 10 more than the other number. So one number we considered as x and x plus 10 as another number. So obviously x plus 10, adding those two numbers should get us 64. So since their sum is 64 here, we have the linear expression. This is the linear expression we are going to get here. X as the smaller number, x plus 10 as the second number or the larger number. It is 64 that we are equating it. Okay, so this implies a linear expression, that is 2x plus 10 is equal to 64. Here there are two parts of this expression you need to concentrate. Okay, hope you understood this explanation clearly. Now you should be noting here that when we equate a linear polynomial to in one variable to a constant, we are equating it to a constant, we get a linear equation. Now there are two definitions that they are giving here in this statement: linear polynomial and linear equation. Okay, there is a small difference in the linear polynomial and linear equation. Polynomial is this part, okay, and when you equate it with the constant 64, the whole thing becomes the equation. You understood this? Simple one. You can see that. So 2x plus 10 is a linear polynomial. By equating it to a constant 64, we are getting a linear equation, that is 2x plus 54. 2x is equal to 54. How we are getting 2x is equal to 54 is by equating this. See, 2x plus 10, which we got by adding x plus x as 2x, and 10, 2x plus 10 is equal to 64. If you take 10 to that side, it will become x is equal to 64 minus 10, that is 54. Okay, let me write that also. So it will get me x is equal to 54 divided by 2, which is equal to 27. Correct? So therefore x is equal to 27. What do we want? It is the smaller number. What is x then? X, we consider it as a smaller number, right? So therefore the two numbers are 27, which is x, and 37, which is x plus 10. Okay, so therefore the two numbers are, what are the two numbers? Are x is equal to 27. That is what we found by equating 64 to the polynomial, linear polynomial, and the second number is x plus 10, which is 37. You see that 27 plus 37, you will get 64. That is the answer for this question. So this example actually explains us what is a linear polynomial, what is a linear equation, and how to solve the linear equation to get the exact value of the variable in that polynomial. Understood this? Okay, now let us see. Okay, now there is one simple concept that they have explained. This linear equation, because linear equation is having one variable which is considered as an input, and the whole expression's value can be considered as an output. Correct? So it can be considered, the polynomials can be considered as input output processing machine. Okay, some interesting concept they are explaining. Assume that this is an expression, or this is a machine which is processing this expression. What is this expression? Expression is y is equal to 2x plus 3, and this is the code inside that machine. And what is the input here? Input is x. Okay, and what is the output? Output is y. Correct? Output is y. So to put the value of x and get the value of y. So there is an example given here. If x is equal to 4, then how does this process is 2 into 4 plus 3, which is 11, and that is the output. Y is equal to 11. So you put in the different values of the input x and get the different values of output y. So it is input output processing machine. So linear expressions or linear polynomials can be considered, any in that case any polynomials in general can be considered as a input output processing machines. You put the value of the variable, that is the input, and get the output as the expressions value. Okay, this is a simple example of that. Okay, now let us consider the exercise set 2.2. These are also the simple examples only. Let us solve one by one. Okay, find the value of the linear polynomial 5x minus 3. Okay, this is the polynomial 5x minus 3. We have to put in x value as 0, 1, minus 1 and 2, and find the value of those. Simple. Okay, let us try to put in the value 5x and x is 0 in this case. So 5 into 0 minus 3, and what is the value of this? It is minus 3, because this term becomes 0. Simple. Let us go fast. Okay, it is minus 1 in 5x. Okay, 5 into minus 1 minus 3. Okay, this is equal to 5 into minus 1, that is minus 5 and minus 3. What is minus 5 minus 3? It is minus 8. Correct? Okay, now again 2. Okay, 5 into 2 plus minus 3, it is minus 3, right? Okay, so 5 into 2, that is 10 minus 3, which is equal to 7. Simple only. Okay, simple. Okay, now another example, similar example only, but here it is a quadratic equation in place of linear equation. Okay, now let us put the value s in place of 7s square 4 minus 4s plus 6 with minus 3 ones and 4 ones. Okay, let us try to put in the values. 7 into 0 square minus 4 into 0. Okay, anyway it is going to be 0 only. Okay, so this is 0, this is 0, so the whole expression's value is 6. Simple. Here you have to be careful while putting the values, because if there is a negative value and if there is a square, it actually makes a difference in the values. Okay, now let us put in the value minus 3 square, it is 7s square, minus 4, and here also you should be very careful with sign only. You have to put in the values. It is minus 4s plus 6. Correct? Okay, minus 3 square is actually plus 9 only. Okay, minus 3 into minus 3, that is minus into minus plus. First of all, you have to multiply the signs, that will give you plus, and then 3 into 3, that is 9. Okay, so 7 into 9, that is minus 3 square. Minus into minus, here also there is a multiplication symbol between the coefficient 4 and the s variable, and the signs of those both are minus, so that will actually give you plus 4 into 3, that is 12 plus 6. Okay, 7 nines are, that is 63 plus 12 plus 6. Okay, 63 plus 12, that is 65, 75 plus 6, that is 81. So the whole value of this expression with s is equal to minus 3 is 81. You understood this? Okay, let us put in 4 quickly and see what is the value of that. 7 into s square, that is 4 square, minus 4 into 4, that is in place of s, that is 4 plus 6. Okay, 4 square is 16, so minus 16. 4 into 4 is also 16 plus 6. Okay, now 16 sevens are, it is 112. Okay, minus minus 16 plus 6, that is minus 10. Okay, this part I've just done it. Minus 16 plus 6, that is minus 10. So subtract 10 from 112, it will give you 102. Okay, so this is the value of this expression with s is equal to 4. So simple examples only. We are just evaluating the algebraic expressions value by putting in the variable, different variable values. You have already done this in the class 8th also. Okay, now this is a little bit different from what we have done till now. Okay, now such examples also you might have studied in the class 8. You can see and you will find that similar kind of problems you have already resolved. Okay, listen to me this carefully. Okay, the present age of Salil's mother is 3 times Salil's present age. Salil's present age, remember this, and 3 times. It is Salil's mother's age is 3 times. You have to remember these two information. Okay, after 5 years their ages will add up to 70 years. So after 5 years, when you add their ages, the sum will be 70 years. Find their present ages. Okay, now whenever such examples are given, listen to me carefully. Whenever such examples are given, when you go to the end of this problem, you will see what is that we have to start with. Okay, you go to the end of the problem and see, there you will find that what we should be starting with. So what they are asking, their present ages. So let us consider their present ages in terms of variables, so that it will get us an algebraic expression solving by which we can get the answers. Understood this? Okay, now let us see what is that. Find their present ages. Now let us consider the present ages in terms of variables. As I already told you, let me write that. Let Salil's present age, Salil's present age, because that is what we want, right? Salil's present age is equal to x years. We don't know, that's why we have considered it as x years. And what is given when it is x, Salil's mother's age will be 3 times Salil's present age. Now we are considering present age as x, so Salil's mother's present age will be 3x. Correct? Mother's age will be 3x years. 3x years. You understood this? Okay, these are the present ages. Now listen to me carefully again. What is the additional information that they have given is, after 5 years their ages, the sum of their ages will be 70 years. Okay, now since present ages are x and 3x, after 5 years, okay, you can say that after 5 years, this is nothing more than adding 5 to the current age. Okay, so if you are 10 years now, then after 5 years you will be 15 years. If you are 15 years, after 5 years you will be 20 years. So only adding 5 to the current age. That's what I'm trying to make you understand. So after 5 years, x plus 5 is the age of Salil. Okay, and 3x plus 5 is the age of Salil's mother. Okay, and what they have told is the sum of this after 5 years, sum of this will be 70. Okay, so I can say this is the expression. Therefore x plus 5 after 5 years and 3x plus 5 after 5 years, and adding these two terms will get us 70. If you solve this, you will get the value of x, that is the age of Salil. Okay, and 3x is the age of Salil's mother. Okay, that is how you get the answer. You understood this? Okay, now x plus 5, 3x plus 5. When you add it, x plus 3x, which is 4x, okay, plus 5 plus 5, that is 10, is equal to 70. Correct? So 10 you take to that side, it will get you 4x is equal to 70 minus 10, which is 60. Therefore x is equal to 60 divided by 4, that is 4 15s are, and that is x is equal to 50. Okay, so x is equal to 15 is the answer. And finally, how are we going to write? Therefore Salil's present age, Salil's present age is equal to x is equal to 15 years. Okay, and mother's age is equal to x plus, sorry, it is 3 times x, right? 3 times x, which is 3 into 15. Okay, that is 45 years. 45 years. This is the answer. Okay, now if you see after 5 years, you can, how do you verify that your answers are correct? Okay, you just put in the information given in the problem. Okay, after 5 years, now if he is 15 years, after 5 years he will become 20 years, and it is 45 plus 5. After 5 years mother's age will be 50 years, right? 50 plus 20, that is 70, and that is what the information given here. So this is how you have to verify that your answers are correct. Understood this? Okay. Now let us see similar kind of example. One more example of the similar kind. The difference between the two positive integers is 63. Okay. Listen to me carefully. Okay. The difference between the two positive integers, we are not given with what are those positive integers, but the difference is 63. The ratio of the two integers is 2 is to 5. Okay, the important information given is their ratio. Okay, the two numbers ratio is 2 is to 5. Find the two integers. We have to find the two integers. You need to be very careful here that they have given two positive integers, so the answer that you get should be positive only. Okay, let us start with the given information that the ratio of the two integers is 2 is to 5. Okay, since the ratio, you can write that since the ratio is 2 is to 5, 2 is to 5. Okay, we can consider, we can consider 2x and 5x are the numbers, or 2x 5x as the required numbers, as the required numbers. You have to write it in this way, required numbers. Okay, and what is given? The difference between those two numbers is 63. Okay, now with the information the ratio is 2 is to 5, we have considered 2x and 5x are the numbers that what we require. Now we can say that with the with this information we can say that and 5x minus 2x, because the difference is 63. So 5x minus 2x is equal to 63, which is given. See how easy that we converted the given problem into an algebraic equation. Solve this equation, get the value of x, then you will get the two numbers also. Okay, now let us see 5x minus 2x, which is 3x, is equal to 63. Okay, and what is x? X is equal to 63 divided by 3. Therefore x is equal to 21. X is equal to 21 according to this expression. Now x is equal to 21 is not our answer. Our answer should be 2 is to 5. Okay, 2 times the x is one number and 5 times the x is another number. That is what our problem says. Okay, now find the two numbers. So finally we can write, therefore the two required numbers, the two numbers are 2x. What did we consider? We started with an assumption that 2x and 5x. 2x is equal to 2 into what is x is 21. One number is 42. Okay. Another number is 5x, that is 2 into 21, which is 105. Okay. So these are the two numbers. This is the proper answer to this problem. Now if you see that the difference between 105 and 42, if you subtract 105 42 from 105, you will get 63. That is correct. Okay. And also if you find the ratio 2 is to 5, you will get, see here only you can get that 42 uh, divided by 105. Okay, it is 21 twos and 21 fives. So it is 2 is to 5. Understood this? This is how you verified your answer also. Okay. Now let us quickly move to the next problem. Okay. Now this is also very important, and converting the given information into algebraic expression. Listen to me carefully again. Okay. Ruby has 3 times as many 2 rupee coins. 3 times as many 2 rupee coins as she has 5 rupee coins. Okay, so if you consider x as 5 rupee coins, then 3x will be 2 rupee coins. Listen and read this problem carefully, that 3 times as many 2 rupee coins as she has 5 rupee coins. If she has a total of rupees 88, this is an information that allows us to form the algebraic expression or the linear polynomial. Okay, remember this. How many coins does she have of each type? Okay, each type, how many 5 rupee coins she has, and how many 2 rupee coins she has, so that the total makes it 88 rupees. That is what the problem is. Remember and listen to me carefully, that in such a problem this can be resolved in different ways. Okay, you can consider x as 5 rupee coin and y as 2 rupee coins, and you can solve for x and y. That is also possible. But since we are discussing these problem in relation to the linear polynomials, we should be always thinking these problems in terms of one variable only, not two variables. You're getting it right? So here in this problem also, we have to consider this problem by considering it as a linear polynomial only. Okay, now let us do it quickly. Let the number of 5 rupee coins, let number of 5 rupee coins, it might take a little bit of time, but you have to write it. Okay, 5 rupee coins is x. Okay, now as given here, 3 times of the 5 rupee coins is 2 rupee coins. So therefore the number of 2 rupee coins is equal to 3x. Correct? Okay, x is 5 rupee coin and 3x is 2 rupee coin. If she has a total of 88 rupees, so when she has x 5 rupee coins and 3x 2 rupee coin, if you add both, you should be getting it as 88. Okay, and given, what is given here is x into 5, that makes the total 5 rupee cost, right? So given is 5 into x, that is the value that makes it with 5 rupee coins, 5x, 2 into 3x, right? It is 2 rupee with 3x coins, right? It is 5 rupee with x number of coins, and that is what is equal to 88 rupees. That is what is given here. Understood this clearly? Okay, now let us resolve this. 5x, here you can see that clearly that I did not consider the x and y for 2 rupee and 5 rupee coin. Okay, try to understand this. Okay, 5x, 2 into 3 is 6x is equal to 88. So 5 plus 6, it is 11x is equal to 88. Therefore x is equal to 88 divided by 11, that is x is equal to 8. X is equal to 8, and x is the number of 5 rupee coins that what we considered. Okay, so finding x will allow us to find the 2 rupee coin also, and that is what we wanted. Okay, each type of coins. So x is 8. So finally you write the answer as, therefore the number of 5 rupee coins, 5 rupee coins is equal to x is equal to 8, right? And number of 2 rupee coins is equal to 3x is equal to 3 into 8, that is 24. Correct? So this is the answer, but you can verify it. Again, you can verify it. So how do you verify? X is the total number of 5 rupee coins, right? So what is x? 8. 8 into 5 will get you how much the amount with 5 rupee coins C has. Okay, 8 into 5. Okay, and 24 into 2 rupee coins, right? 24 2 rupee coins are there. So this is actually 48 rupees with 2 rupee coins she has, and 8 5s are 40 she has with 5 rupee coins. So 40 plus 48, that is 88. This is how you verify your answer also. Okay, after solving the problem you have to verify your answer by uh, reverse engineering, you can say that. This is a reverse engineering process. Okay, now let us consider the next problem quickly. Okay, what does this says? This is a very simple example. You have to be careful while reading the problem. You will get the answer very easily. Okay, a farmer cuts a 300 feet fence. You see that the fence that I have explained in the previous example, the example in the introduction. There is a fencing, there is a wire. You consider there is a wire with 300 feet. He cuts it into two pieces of different sizes. Okay, of different sizes. The longer piece is 4 times as long as the smaller piece or the shorter piece. Okay, now assume that this is the wire with 300 feet. Okay, totally it is 300 feet, right? That is what they have given. He cuts into two pieces. Suppose this is the uh, uh, two different pieces of different sizes. That's why I've made it as one as larger and one as smaller. Assume that the smaller size is x. Then what they are saying is it is 4 times. The larger size, whatever you have, is 4 times the shorter size. So it is 4x. If x is the length of the shorter size, shorter piece, then 4x is the length of the larger piece. Now you got the answer right. 4x plus x is equal to 300 feet. That is what the answer given. Okay, so if you add up the length of the two cut pieces, you should be getting it as 300 feet, because originally it was 300 feet. Okay, so given, or else you should start with let length of smaller piece, length of shorter piece or smaller piece, whatever you write it as, shorter piece is equal to x feet, is equal to x feet, you can say x feet, and length of larger piece, larger piece is 4x, right? 4x feet. And given is 4x plus x, sum of both the cut pieces, and originally it was 300 feet, right? Okay, so 4x plus x, which is 5x, is equal to 300, and x is equal to 300 by 5. X is equal to 300 by 5. Therefore x is equal to 5 ones are and 5 6 the 30, it is 60 then. Okay, x is equal to 60. What is x that we started with as the length of the shorter piece, that is x feet, which is 60 feet. So the answer is 60 feet and 4x, that is 4 into 60, 240 feet. Okay, so therefore the final answer is the length of shorter piece, the length of smaller piece See, while writing the answer, it might take a little bit of time for me, but you have to write all these descriptive answers while solving the problems. Okay, that's why I'm taking a little bit of time to write all these answers also. Okay, so the length of the smaller piece is x, which is equal to 60 feet. Okay, and the length of the larger piece, you can write it in detail. I'll just write length of the larger piece, that is 4x. You have to write it in detail. Okay, so 4x, which is equal to 4 into 60, that is 240 feet. 240 feet. So you can just verify here, 240 plus 60, which makes it 300 feet, which is the original length of the fence. Understood this? Okay, let us quickly move to the next problem. If the length of a rectangle is 3 times more than twice of its width and its perimeter is 24 centimeter. Read this very carefully. It's very, very important, because analyzing this in a little bit of different way will get you the different answers. Okay, listen to me carefully and read it. Okay, I'll read it again. There is a rectangle with some length, they are saying. Okay, there is, assume this is a rectangle, and they are saying the length of a rectangle is 3 times more than its width. Now assume that its width is x. Assume that first the width of this is x. Okay, what they are saying, 3 times, sorry, it's not 3 times, it is 3 more than. So that is why, see, now I only got confused here, that while reading it is 3 times is different from 3 more than. Okay, so they are saying 3 more than twice its width. Twice its width. Now first of all, consider, if x is the width, twice of the width makes it 2x, right? Twice of the width is 2x, and twice of width 3 more than, so adding 3 to this. See, this is what the way to analyze it. That's why I'm saying the length of the rectangle is 3 more than, it means plus 3 twice its width. If I consider width as x, then twice width will be 2x, so the length of the rectangle will be 2x plus 3. Okay, and its perimeter, they are saying, when you sum up all this, its perimeter will be 24 centimeter. What are the dimensions of the rectangle? We need to find out what is x and what is 2x plus 3, so that length and width we will find out, and that is the dimensions. The dimension means what is the length and what is the width. That's all. Okay, now consider, let I will write it here, let width be x, width of the rectangle be x. Okay, so length will be, if you want, you can write it in more detail, that width of the rectangle and length of the rectangle. I am writing it in a short form just to save the time. So length is, therefore, since it is given as twice of the width plus 3, 3 more than twice its width, so x and 2x plus 3. Now what is given is perimeter. Okay, so given is, or before given, we know that know that perimeter is, what is perimeter? What is perimeter of a rectangle? Perimeter of the rectangle is 2 times length plus breadth, or length and width. You can consider it as length and width. So it is actually 2x plus 3 plus x plus 2x plus 3 plus x, because the opposite sides of the rectangle are always equal. Okay, so it is 2 times length and width. I will not explain this because you might be knowing this. Okay, so what is perimeter? They have given it already, it as 24 centimeter. 2 times length. What is length? Length is 2x plus 3, and plus width, that is x. Okay, so therefore let me write this as, therefore 2 times length plus width, let me write it like this, 2 times, what is length? 2x plus 3, it is length. Okay, and what is width? Plus x, and what is that is equal to perimeter, and what is the perimeter that they have given? That is 24. I just wrote it in a swapped way. Okay, left side I taken it to the right side just to make it as a algebraic expression, that's all. Okay, now add the values inside the bracket and take 2 to that side. Okay, so so that 2 goes into the division of 24. So what is 2x plus x? That is 3x, right? 3x plus 3. Okay, listen to me carefully. It is 2x plus 3x, which makes it 3x, and this 3, which is constant, I am keeping it as it is. So it is equal to 24 divided by 2, that is 12. That is 12. So it is, so the next step is 3x. I am taking this 3 to the right side and dividing this also. 2 ones are and 2 12s are, right? So it is 12 plus 3 going to that side will become minus 3. Okay, so it is 12 minus 3, 9. So therefore x is equal to, what is x? X is 9 by 3. Therefore x is equal to 3. X is equal to 3. You understood this? And what is x that we started with? Is width of that rectangle. So the first dimension of that is width, x, feet. Feet, or what it is given, centimeter, sorry, it is x centimeter, that is 3 centimeter. And then put the value x is equal to 3 to get the length of this rectangle also. So finally you will write it here, you will write it here. Therefore the width of rectangle, width of the rectangle, you can write it as x is equal to 3 centimeter. Okay, and length I will write it as, these are the dimensions. Okay, length is 2x plus 3, right? 2x plus 3, which is equal to 2 into 3 plus 3, that is equal to 2 into 3, that is 6, plus 3, that is 9 centimeter. If you want, you can skip some steps also. So just for the detailed description, I have just given this as a step-by-step explanation. Okay, so 3 centimeter and 9 centimeter is the dimension of that rectangle. Okay, which gives you all this information. Okay, you can verify that 9 centimeter and 3 centimeter as length and width, whether you get the perimeter as 24. You see that if this is 9 centimeter, this is also 9 centimeter. 9 into 9, sorry, 9 plus 9, 18, plus 3, 21, plus 3, 24. So it is a 24 centimeter perimeter rectangle. We got it with this information. Understood this? Okay, now let us see what is there next. Okay, now we will see this concept of exploring the linear patterns in the next session. We have done with the exercise set 2.1 and 2.2 in this session. Okay, let us continue our discussion on the exploring linear patterns in the next session. Okay, thank you.